Hello and welcome to my presentation titled Something Fishy About Manchester United's Distribution of Goals Scored. This presentation is part of the virtual colloquium series hosted by the Math and Computer Science Department at Wittenberg University. So first of all, a little bit about myself. That's me. My name is Quang Nguyen. I am from the beautiful country of Vietnam. I am a 2020 graduate of Wittenberg University. And during my 3 years at WIT, I was double major in mathematics and data science. I am currently a graduate student at Loyola University Chicago, pursuing a Master's of Science degree in applied statistics. And I love working with data and numbers, and I am interested in a career in data science, which is a very exciting, hot, and sexy field out there nowadays. So next, I'm going to give you a quick overview of this presentation. So for this presentation, I am actually going to cover a section of my honors thesis, which I completed during my senior year at Wittenberg under the direction of Dr. Andrews of the math department. The topic of my thesis was statistical models of English Premier League goal scoring, and this talk will highlight one of the models that I looked at, and it is the relationship between the number of goals scored of my favorite team, Manchester United, and the Poisson distribution. So this project involves ideas from many different areas like statistics, probability, and data science. And you probably have seen most, if not all, of these ideas from introductory level courses at Wittenberg or elsewhere. So these terms include exploratory data analysis, different models, hypothesis testing, and also probability distribution with properties like mean, standard deviation, variance, and all the codes for this project were written in my good friend R, which is a very awesome statistical software. So like I just mentioned, this presentation will focus on Manchester United. So who are they? So I am a diehard supporter of this club as I've been following them since I was like 3 years old. And United is one of the best and most famous club in the sports of football or soccer, as we often call it here in the United States. That's Man U's logo. And this club has a great history of dominance in the country, England, and also in European competitions. The team has won many football trophies, most noticeably a record of 20 domestic first division title in England, which includes yet another record of 13 English Premier League trophies. United is also known for having some of the very best coaches and players in the history of the game playing in the uniform, with legendary coaches like Sir Matt Busby and Sir Alex Ferguson, and players like George Best, Bobby Charlton, Ryan Giggs, David Beckham, Cristiano Ronaldo, Wayne Rooney, and the list just goes on and on. And Man U is one of the most respected and beloved sports brands around the world, as you can probably find a fan of this club anywhere on this planet. So anyway, those were some information about Man U. And as mentioned before, we would like to analyze this team's just goal scoring. But why goal scoring? Well, the significance of this idea in football is that it directly determines the outcome of each individual game. So the rule is very simple. In order to win, you must score more than your opponent. And as you probably know, there are three types of results for a team in soccer: a win, a tie, or a draw, and a loss. So our big question here is, does Man U's number of goals scored follow a Poisson distribution? And so to that end, let's talk about this Poisson distribution. So first up, a little bit of history here. So this distribution is named after French mathematician Simeon Denis Poisson, and it was discovered in the year 1838. And that's Mr. Poisson. It is a discrete distribution. So the word discrete here means that the distribution shows the probabilities of countable outcomes. And we also have another type of distribution called continuous, which has a range of values that are infinite and uncountable, but Poisson is discrete. And Poisson illustrates the probability that a certain number of events happen within a certain time period, and a Poisson random variable can represent many instances in our daily lives, such as the number of phone calls coming into the math workshop requesting a tutor in a week, or the number of cars arriving at a fast food drive-through in an hour. And a little fun fact here. So Poisson is French for the word fish. And so here are a couple of memes about Poisson. So I don't know if you're a mathematician, but my wife is not happy with her Poisson distribution. And have you ever heard the joke about Poisson distributions? It's pretty fishy. So hopefully by now you can tell why the word fishy appears on the title of this talk. But anyways, back to the topic of Poisson distribution. So if we let x be a random variable, so this term just means that a variable whose value is a numerical outcome of a random phenomenon. So if x follows a Poisson distribution with parameter lambda, then x has this probability function where, again, x is the number of times an event occur in a given time period, and lambda is our constant rate parameter. There are also two important properties of a Poisson random variable, which are its mean and variance. So the mean, or the expected value, or the average value, often denoted by the Greek mu, is equal to lambda. And so is the variance, which is a measurement of spread, in particular, how far a set of values are spread out from the mean value, and it is denoted by sigma square. where the Greek sigma is the standard deviation of the distribution. And now let's look at the data that we're using to determine the relationship between Manchester United's number of goals and Poisson distribution. So here we have a data set consisting of all final scores for Manchester United from all Premier League seasons from the first year, 1992-1993, to the last fully completed competition, which was the 2019-2020 season. And the variables of this table are the season, the home and away clubs, and how many goals each team scored in each match. And a quick note here. So when I was in the process of working on my thesis, the 2019-2020 season was still taking place. And the season just ended in July 2020. And so I just recently added the data for the season and reran all of my codes and got the new results for this presentation. So now with any statistical analysis process, the first task is to explore the data, examining distributions of the variables using graphical and numerical summaries. And this should always be done before any model fitting because we must understand our data thoroughly before doing anything else. So we begin with some basic summaries of Manchester United's number of goals. So visually, we have here a histogram of goals, as you can see. And numerically, our software R gives us the number of matches, which is 10,076. The mean and standard deviation for number of goals, 1.910 and 1.403. And so we're going to compare the mean and the variance of man uses goals, and we are hoping to see these two values equal to each other since we know that the mean and the variance of a Poisson variable are the same. And so with some simple computations, the mean is 1.910 again, and the variance, which is the square of the standard deviation, so we just take the square of 1.403 and get 1.969 for the variance. And so they are pretty close to each other. And this is exactly what we anticipated, and it is a good sign for us. So those are some basic exploratory data analysis for man use number of goals. And we are now going to tally up the possible values for number of goals scored and the counts of the matches having those goals values. So as you can see, here are the possible values from 0 to 9, and here are the matches. And so since there are only a small number of matches with 4 goals or more, as you can see here, it'll be a good idea to combine them into a single category called 4 or more. And a more important reason of doing this is we want to meet a condition for a chi-square goodness of fit test, which we'll be conducting shortly. So the test is appropriate when the expected value of the number of counts in each category is at least 5. So if we just leave it like this, for these last 3 categories, we don't have the 5 observations that we needed for the chi-square test. And so here's our new table with only 5 categories for the number of goals: 0, 1, 2, 3, and 4 or more. And they should add up to 1,076, the total number of matches. And we're going to compute the Poisson probabilities for our goals values using our mean 1.910 as the rate parameter. And we're going to utilize the probability function of the Poisson distribution to calculate this. And thanks to R, which has a function to do this for us, these are the probabilities that we got. And to get the expected matches for each goal value, we multiply the total number of matches, 1076, by the Poisson probabilities. And here's what we got for the expected matches, which is what our model predicted for the number of matches. And just by looking at the value of the expected matches, we can tell that what was predicted by our Poisson model is very similar to the actual number of matches. And this is another great sign for us. So now we would like to compare them a little more. So this bar plot right here is a visual summary of the number of matches obtained from our Poisson model and the theoretical or actual number of matches for each goal scoring category. And as you can see, it looks amazing. They are almost the same for each category. And so we would like to confirm this fit, and we're going to use the chi-square goodness of fit test. So what is a goodness of fit test? So the idea is pretty straightforward. It is a hypothesis test that describes how well a statistical model fits a set of data. And the chi-square test is extremely useful for us here, since it is used when we have categorized data, meaning that data are counted and divided into different levels of categories, which we have here with our goal scoring categories. So we would like to test whether number of goals scored for Man U follow a Poisson distribution. And here are the null and alternative hypotheses for our test. And again, we took advantage of R, and here are the results that we got. So we have a chi-square of 0.538 for our test statistic and a p-value of 0.970. So since it is a big p-value, we do not reject H0, which means that there's not sufficient evidence to support a conclusion that our data cannot be modeled by Poisson distribution. And we're now going to use the idea of the power of a hypothesis test to make a final conclusion. So the power of a test is the probability that it will correctly reject a false null hypothesis. And it is highly influenced by the sample size. So the larger the number of observations, the higher the statistical power of a test. And here, since we have a large sample size of more than 10,000 matches of Manchester United, it is safe to say that our chi-square goodness of fit test has high power, and hence we can conclude that the distribution of Manchester United's goals scored is consistent with a Poisson distribution. And our initial suspicion has been confirmed. And ta-da! And so for this project, I would like to give a special thanks to my thesis advisor, Dr. Andrews, for all of the helps and advices throughout the course of this project. I would also like to thank the math and computer science department at Wittenberg for providing me the knowledge during my time here. and also for giving me the opportunity to work on this amazing honors thesis. And also a special thanks to my Wittenberg friends, especially my math and data science majors, and also my fellow math workshop colleagues. Thank you for everything. And last but not least, so if you are interested in taking a closer look at my thesis, please visit this website link. And in addition to what I presented, you'll be able to find all of my codes as well as several other models of goal scoring in the Premier League by viewing the full version of my thesis. I've also included my email here, so if you have any questions about this presentation or my thesis, or just simply want to talk about data science or sports analytics, even grad school or soccer in the Premier League, feel free to contact me. I'm more than happy to share my knowledge and also network with you. And that's it for my presentation. Thank you for tuning in. I hope you enjoy it. Take care and be safe.